Hello, everyone. It is May 14th, 2024, and this is the bi-weekly Libhal meeting. It's been a while. I've been busy with a lot of variety of things, and I kind of got a little flustered or mixed up when I realized I couldn't get a time that worked with everyone. But I think, after a while, I was like, I need to just start this back up. So yeah, it's been at least a month. I think April 20th was our last meeting. All right, for the agenda, I want to give a couple shout outs to people who've been working on libhal support for other platforms. That would be Gene and Madeline. Gene working on the STM32F4. We got a couple of drivers for that. I'll talk about that more later. Madeline's been working on Linux. That's been awesome. Really excited to see as we continue to grow that out. And also, that work on Linux has also put us in a position where we really need to start considering cross compilers and how to best ensure that we can compile to whatever targets we desire. We also have STM32F1 support. I've been the one doing. Milo has done the input pin, and I did serial and CAN. I'll talk about that later. I'm also going to talk about this journey into USB, and I'm also going to talk about the API break that happened with Libhal. So Gene ported over, pretty much soloed STM32F4, porting that over to Libhal. That was fantastic. This includes, getting the Conan file set up, the CMake file set up, making it set up between the demos and the packages, upgrading from Libhal 2.0 over to 3.0, as well as, this just today we did it over to 4.0. But when you see what's required to make it over to 4.0, it's not the biggest deal, but 2.0 to 3.0 was huge. And he also made sure to add in all the different linker scripts that we need. Or at least we have one base one, I think. I forget. But adding that support's also another little complication that comes with setting up your Kona package for a platform. We currently support output pin, input pin, and SPI. The DWT counter, which we use as a steady clock for things, doesn't seem to work on it. So right now we have to do just this polling a volatile variable to basically just loop for a while. We'll figure out why that exactly is happening, but for now, you can't really use the DWT counter. Linux support. Madeline ventured out to figure out how we can support Linux with libhal. She added in support for output pin, input pin, serial, and I2C. I believe Madeline also, she posted on the discussions a while back in the Discord, but she basically showed, her being able to take one of her demos that was used for the Mimic arm. For those who don't know what the Mimic arm is, it is a scaled down version of a robotic arm that a human can adjust, and it sends communication to something, usually a computer, that then relays the information back to the real arm, and the real arm moves in response. So it allows us to, control a smaller version of the arm, which is a lot of times a lot easier than trying to use a controller to control an arm. That layer of abstraction between the two goes away once you have the full mimic. She was able to get that to work pretty much perfectly fine with I2C and using the I2C devices that we have there, demonstrating that we're able to take our libraries between different platforms and they just work, which was the plan the whole time, but it's nice to actually just see it fully happen. We don't have a cross-compiler solution for this yet. So if you wanted to do this, you'd either need to emulate a VM or build it on the target device. This is something that me and her have been talking about a lot. I think our solution to this might be the Zig compiler, funny enough. I think the Zig compiler has a lot of things going for it that makes it a really good choice. It supports Linux extremely well across different architectures, and they've been building up that sort of support. I believe they also have, I don't know if you'll ever use this, but they have cross OS support as well. They have really strong to Windows and to Mac. If we ever, for some reason, delve into the world of embedded Windows, which is a thing, there are versions of Windows that are dedicated specifically to embedded systems, but it's just a stripped down version of as far as I'm concerned, XP or 11 or whatever. But what's more important is that they have a really good framework for how they do their cross compilation, and there's also the LLVM Clang for ARM that exists as well. Now we could take those parts, somehow try to smush them together. Zig just uses Clang underneath, uses LLVM underneath. We can maybe squish those parts together, get something that works really well for Linux and ARM, and then see if we can then venture out to figure out how we can jam in RISC-V and any other architectures we want to support. I feel like after we get a couple of these in ourselves, we'll get some experience to that, and then we'll be able to support anything we really desire. At least have a compiler that can compile to basically anything. And the compiler can already do all this stuff. It's more about linking. That's the final stage. That's usually the biggest issue, where you get your libc from, that kind of stuff. But yeah, also planned is CAN, SPI, and timer. And then maybe some bonus things would be like ADC and PWM, which is part of Linux's industrial drivers area. But we're still, I think at the moment, not sure if those are Linux kernel level or just user space. But I think Madeline last time told me it was just user space. Next up, we have STM-F1 driver support. So the STM32F1 supports output pin, input pin, serial, UART, and CAN. That's about it. Malia Labor worked on input pin. That was her contribution. I worked on serial about last week, and then I got CAN working last week to this week, which was a lot more complicated than I thought. Planned usage for the STM32F1 board, and the reason why I'm focusing more support here is that we want this to be the target device that SJC Robotics uses. The LPC, I love the LPC so much for so many different reasons. I also love its data sheet. That's one of my biggest reasons. It is hard to find right now because a lot of people probably feel the same. But the STM32F103C8 is very abundant for some reason. It's still well loved. People love this chip, but it is just really available on pretty much all websites, DigiKey, Mauser, and LCSE. So moving over to this, which is a lot cheaper as well, we're able to cut down the cost per board from like what was probably around $15 before, might even been like closer to $20 each. Oh yeah, actually, we bought the LPCs scalped. So at one point, so it was like I think $20 per when we were getting desperate. I think I just paid that out of my own pocket. I don't think I levied that over to the robotics team. But yeah, so that was the thing. We don't have to worry about that anymore with the STM32 F1s. So yeah, planned up is I2C, SPI, timer, PWM, ADC. Oh, watchdog. I didn't add that in there. We need to make a watchdog interface. That would be fantastic. But on top of this too, also HAL USB. So now I'm going to talk about starting HAL USB. Amelia brought up the desire to really bring in USB. And it's basically because of the fact that there's so many things you could do with it. Like you can make keyboards. We could, if we had a powerful enough MCU, make cameras, microphones. I don't even think making a microphone even be that hard. Okay, to the back. I've technically done something very similar to this in a previous life. So I have an idea how to make the microphone work. But yeah, a USB microphone would be not too crazy. Actually, to be fair, if we could on a device, if there's an I2S port and you can DMA it into a port of USB, like into one of the endpoints of USB, which I don't know if that could work when it comes to timing. Maybe that could work. But basically, yeah, DMA from microphone into a buffer, DMA from buffer into the endpoint, and just shoot the thing back and forth as it streams data in. Bob's your uncle. We got a microphone. Gamepads and joysticks. The cool thing about making your own is that you can make your own. You can put as many XY axes, any buttons, any adjustable analog values, just things like that. Like you can do the whole gambit with when you basically can make your own USB device, which I think could result in some really cool projects. You could also have it act like a storage device. You could literally have it interface with actual storage. If you wanted to, you could interface between things that don't usually have storage interfaces. Like, for example, USB SPI flash devices. You could have your device come up as, you could have it talk to EEPROM. You can have it do a lot of different things, but one of the other cool things you can do is use it to install firmware. I love that a lot of Adafruit and other new devices basically are having their bootloaders, the baked-in one, basically present itself as a USB flash device or storage device or mass storage device. And then all you have to do is, drag and drop your bin file into the device, and then it flashes itself. Like that's, to me, really, really awesome. I really love that that's a capability that, a device can just do over USB. I don't know if I guess I have to think about that a little bit. Like, I guess you have to do some like fat image decoding as you stream it. But yeah, but yeah, no, I really like that. And one idea that comes to my mind is that let's say one thing you can do already to some degree is you can use GitHub, um, not Copilot, sorry. It is the thing, workspaces. So just you can build and compile all of your Libhal code on the web. You actually don't need to download it and install it on your computer. You just have that workspace just there. There's no reason why you couldn't, download a file from that directly after you built it directly into your flash drive, file on your, download list, and then just flash your device. You wouldn't even need to install anything on your computer. You could just have that instance made for you. Shoot, we could have that as a Docker image. I think you can even like make your own workspaces and upload them to GitHub. If you can't, that'd be a cool thing if they added it. But if you can, I know you can do that with actions. So I feel like you could do that with workspaces. So yeah, I think that would be a really cool thing where people don't even have to install anything for Libhal. They just kind of go to GitHub workspaces and go boop, and opens up for them, and they can start going immediately. And another cool thing is that we always have to support serial ICs for usually flashing. But if you're in a situation where either you have a bootloader that works over USB, which is magic, I mean that'd be really cool, or if you have your own bootloader and you trust yourself enough to just do all you're going to do all the serial communication over USB, then yeah, you could get rid of an entire serial IC and just use the built-in USB pins. And then finally, you can be a network device. Who knows? Maybe you can be like a network device over like LoRa. Might not be a good connection, but you could make your little computer, like your little device, into like a really slow speed internet connection. I don't know, just thoughts. Now, the way that I've been thinking about the interface is basically akin to this. I'm trying to think. Oh, there's gonna probably be some other APIs like stall and that kind of stuff. If you know USB, then you may know what I'm talking about. But the core of this is that I kind of just want there to be a write and read for a particular endpoint. I might make a write and read for the control endpoint because that one's kind of unique. You should, after you've enumerated, you should almost never use the control as far as I remember. Unless you're commanded by the host to talk to it for about setting itself up. But besides that, like, control should basically only be hit by whatever's handling enumeration or devices that have information or objects and code that has information that can be used during enumeration. But afterwards, USB devices, after and actually let me explain a little something. So for those who may not know what enumeration is, when you plug a USB device into your computer goes through a process of enumeration. So let's say I plug a device straight into my USB host device and there's no bus, there's no other hub inside of my computer, because you can have devices that act as hubs inside your computer and then talk to your CPU. The way that USB works is that when you first connect it, the device gets an interrupt saying, "Hey, we got a new connection." The host can then say, "Hey, can you tell me who you are and what you do?" And the device will then spit back out, "Hey, who I am? Here's what I do." And it'll keep asking for different bits of information, like, "Oh, can you give me the string at index 3? That indicates your manufacturer information, your manufacturer name, that kind of stuff." So there's this exchange of information where the host gets as much information from the device so it can understand how it should basically control it or use it or present it to the user. And after that's done, one of the things that you do is any sort of driver that uses USB will effectively have a set of mailboxes where they have kind of defined we're going to look at information from. That's what these little endpoints are. So there's endpoints 0 up to I think 16, and there's a write and a read version, or sorry, an in and an out version. Just all you have to know is that each one of these gets mapped to a specific thing, like, oh, I want to be a gamepad, I'm going to use these endpoints. Oh, I want to be a camera, I need to use these endpoints. If I want to be a serial device, I need these 3 endpoints, or maybe only 2 endpoints, depending on how much functionality I want to give to the host to control me. So yeah, these are all things about USB. So I'm hoping that I can get an interface that's as simple as this, so that when a developer goes and implements the driver for it, it's as simple as shove bytes into this endpoint or read bytes out of this endpoint, and that is it. Maybe we will do a callback on this. If it's interrupt driven completely, then we might need to do that, but that's the hope. I think the goal is to make this as simple as possible for the implementers so that they can just get in, get USB to work, and get out, and then let maybe another layer handle controlling things. So yeah, that's pretty much USB. I think I might have had, oh yeah, that's pretty much USB. So yeah. All right, so I think the final section here is the Libhal 4.0 API break. Only thing that I broke is that CAN settings no longer has these items in it. I removed, these sections are meant to explain how many clock ticks each portion of a single bit of CAN communication should take up. And also specifies when the device should sample the line to go, okay, the line has spent enough time propagating to its necessary state. I'm going to sample it, wait a little bit longer, and then I'm going to transition to whatever. If I'm sending something, then I can put out the signal that I want, then wait a couple more cycles before I transition. Or when you read before you transition, you continue to read it for another signal or another bit. So the problem with these tuning parameters is that they necessarily require you to know what the operating frequency of the CAN peripheral is. Effectively, if I want to achieve this baud rate, I need to know what baud rate I want, the clock speed that I'm operating at, and then I need to then figure out how to set up all these numbers. This one is constant. You can't stop sync segment from being 1. It's always 1. But you can change propagation delay to 1. You can move phase segment to 1 and phase segment 2 to 1, and then this thing can be 1 or 0 or something like that. Well, actually, I believe it can be equal to or less than these segments here. But the main thing is that you need to take the baud rate and the current speed in order to know how to segment these parts out. And there's no real way to do that without having the input frequency known, or at least whatever input frequency the bit rate, the output's going to be using. So I stripped those out because there's no way I think that this is overall a mistake in how I made my API, because when I think about how this could be used, maybe the user could use this because, or the person making the application who's building the platform file, they could know what frequency their system's operating at. They could call whatever their system's frequency function is for a particular thing, get that speed, and then do whatever they need. Potentially. May not be possible in all things like Linux, but let's say that they could. Could any device driver using CAN ever be able to know this? The answer is no, unless somehow you also passed the operating frequency of the CAN to that driver as well, so that it can then calculate what these should be for whatever baud rate it wants to set. With all of that being said, basically this adds a annoyance and another thing you have to do in order to get this whole thing to work. It's bad design. So we remove them, and that's the current break. Now, in order to fix this, before I get there, I want to talk about where this all stuff goes though. So now there's a function called calculate CAN bus divider where you give it your operating frequency and your target frequency. This is what your peripheral will give to this thing. And it does all the work of calculating your clock divider, your propagation delay time, your phase segment 1, your phase segment 2, your synchronization jumps width, and this is just the total time quanta, which is just the sum of all these values here, which might be useful to some implementations to have that. Why do I have it as a separate thing rather than having it as a function? This is actually for testing, but I left it there. This thing's already not aligned to 4 bytes anyway, so I'd rather use the extra padding for this guy. Now, you call this function, you give it that information, it gives you back this, and you can pretty much put it in verbatim into your registers, and you're pretty much good to go. I did find, though, that segment 2 can be a little bit too long, so in some code, if you look at the code for CAN for STM32F1 and LPC 4078, you'll find that I have to subtract some of the segment 2 from this, cap it off, and then give the extra to phase 1 just so that it fits inside the registers, because there might only be 3 bits for segment 2 and only and up to 4 bits or even more for phase segment. So yeah, that's where this went. This is now a little helper for CAN peripherals, which would making the drivers a lot easier when it comes to setting up the baud rate and all that. So in order to move from Libhal 3.0 to 4.0, you simply need to change the Python requires for Libhal Bootstrap from 1 to 2. This will change all the requirements for libraries, for device drivers, excuse me, sorry, for demos, everything. So if you change this for your demos, you change this for your library test packages and for your libraries, and this will do all the work. If you don't have any driver that interacts with can at all, all you have to do is change the number and then make a new release of that, and you're solid. That's all you have to do. If you do touch can, I found that almost every single library didn't care either, because almost no library actually touched the configure function. Only that ever did were demos that used can, or the can drivers themselves because they needed to look at them. So LPC 4078 and LPC STM32F1 are the only libraries that actually had any significant change after making this change. And the cool thing is that now setting up the clock rates for can became like just stupid easy, because I have an algorithm that just solves the answer to what should all those constants be. And yeah, now I realize that I didn't realize that the STM32F1 on the internal oscillator could actually reach 1 megabits per second for can. My algorithm spit out some numbers, I threw it in, and it worked. It worked flawlessly. It actually worked extremely well, which was really impressive. And I was like, oh, cool. This was the best option the entire time, and I just didn't realize it. So yeah, that's pretty much it for this meeting. Any questions?